I don't think this will come as a shock to you, but it is currently the month of May, and every May there is a community challenge called Mayterials, where every single day you make a procedural result using nodes. Some people use Substance. I'm going to be using Blender, where you're just trying to fit the prompt. So today, day one, I'm behind, so I'm just doing day one. The prompt is scrap, so I'm going to show you, let me show you what we're going to be making here, how to make a piece of corrugated metal out of a cube, which may seem strange if you've never, touched vector displacement and all this, but yeah, you can turn a cube into pretty much any shape, in this case corrugated metal, and here are some of the things that I've included here. So not only does it look kind of like a metallic piece of scrap, which is why I picked it, but additionally we have some extra sliders. I have the rotation of this, so I want to control this inside the material, which again might be a strange concept to you. You're not rotating this in terms of geometry, but just the material. We'll explain it. That, and I also included a kind of size of this thing, slider. That keeps the same amount of spacing between the corrugated folds and all this. So, if you are interested in learning this thing with vector displacement, yes, it's going to be a bit overwhelming. Get excited. Only other thing I want to say before we start here, I don't know why I keep going in and out of full screen. All these previews on top of the nodes, I have an add-on. You don't need it. It's called Node Preview. I use it to help explain these kinds of things. But there's a link in the description. It's an affiliate link if you're interested in that. Anyways, let's make a piece of corrugated metal out of a cube. If you haven't seen vector displacement tutorials before, buckle up, okay? It's about to get crazy. So, first thing we need to do is we need to set up our scene, and then we're going to hop into the nodes. So what do I mean by that? We need to first of all be using cycles, because displacement, vector displacement, all this only works with cycles. In Eevee, it will not even show up. So use cycles. I'm going to be using GPU, and additionally, I'm going to be using experimental mode, and the reason for this is when we are going to be subdividing our mesh, so the more geometry we have, the better our displacement's going to be. When I'm subdividing this mesh, I'm going to be using an experimental feature. That's called, so I'm going to add in my subdivision surface, adaptive subdivision. So that's not going to show up if you don't have experimental, okay? So you've set this up. Last thing we need to do, two things. In the material, go to settings. This is giving me November vibes. I did a lot of November tutorials back in the day, if you didn't know, but in your material, make sure to set the displacement to displacement only. This is going to make it so that the displacement actually does something, and we don't do displacement and bump because it gives weird lighting issues, okay? We've done this. Final thing before we can actually get started. I know there's quite a bit of prelude. I'm just going to load in an hdri for good lighting. So hdri environment, when we go to rendered mode, we're actually going to see it, and it's going to give lighting interactions and all this. Don't need the light. However, I don't actually want to see it itself. So render tab, film, transparent. Okay, we have now fully set up. We are now ready to start the vector displacement and making a corrugated sheet. So, shading workspace, let's make a material. I'm going to call this Patreon because it's going to be available there if you want to play around with the blend. Check it out over there. This is going to be our corrugated metal material. So, really, there's two kind of steps to this. The first one is we want to do the vector displacement, which if you don't know is kind of a displacement that's more freeing. You can kind of do whatever you want. We're going to do the vector displacement to change the shape of this cube. I'm going to flatten it into a sheet and then add some sine waves. So that's the shape of it. And then on step two, after step one, we're going to be making it look metallic and adding rust and stuff like this. So starting off with vector displacement. Basically, the way you want to think about this is we are not going to be touching the surface at all. So I just hid this BSDF H to do that, H for hide. We're not going to be touching this at all. The only thing we care about is this displacement socket. And if you didn't know, you can just plug in any vector or color into here. So for example, if I was to take a color, plug it into the displacement, you can see it's moving around the cube. Colors are basically three-dimensional vectors. They have an X, Y, Z component, and we're telling the cube to move in that vector direction, okay? Very important, displacement isn't the final location of the vertices, it's just the transformation from one to the other, okay? With that in mind, we're gonna use texture coordinates. Which coordinate system are we gonna be using for all of this? We're actually gonna be using generated. The reason for this is the only coordinate system that moves with vector displacement. Don't worry about it. We need to use generated. However, the caveat is if it was up to me, I'd be using object coordinates because this tells me the position of everything on this cube invariant to changes, right? It sticks with it. So somehow I need generated coordinates that have this property that stuff moves with it. It's the one we need to be using. but I want it to look like object coordinates. So we're just going to start like that. So I'm going to take a vector math node through generated coordinates. I'm just filtering it. I'm going to add, you're going to notice generated coordinates look like this, and object coordinates are centered. If we can actually view it, they're centered on the middle of the tile. So we kind of need to simulate that. I'm going to add in the vector. I think it's going to be 0.5, 0.5, 0.5. You can see we're actually getting our coordinate system to look kind of similar. So we're going to add by negative 0.5. The way you want to think about this is originally the origin was in the corner of the bounding box. We just shifted it by 0.5, 0.5, 0.5 towards the center. Okay. So far you can see here's object coordinates, just raw object coordinates, and here's our modified generated coordinates. They kind of look the same on the mesh. Last thing we need to do is we just need to scale it by 2. Just to make sure that it's going 0 to 1 in every single direction. So long story short, object coordinates look like this. Modified coordinates look like this. They're identical. Only difference is the underlying coordinate system is generated, which is what we want. Okay? So we can just tuck that away. We don't need it anymore. To use this for our vector displacement, what we're going to be doing is we're going to use a subtraction and just subtract it from itself and plug that in. Okay, why do I do this if nothing changes? Well, when you subtract something from itself, it gives 0. In other words, we're changing by 0. So that's why there's no displacement change if I plug or unplug this, right? But we're subtracting it from itself because the way I want you to think about this is all the work we're going to be doing goes from here, our modified coordinate system, to here. So we're just going to be filling in a bunch of nodes here. And then we're going to subtract away these original coordinates. So again, we care about a transformation, not the final position of the vertices. This is why we subtract away this original position, so it's a transformation. Don't worry about it too much. Long story short, all our work is going to be done here, so let's actually start doing some of that work. First of all, I want to flatten the cube and corrugate it, add some sine waves. To flatten it, all we need to do is, if I was modeling this, I'd take it on the z-axis and shrink it like this, right? So let's do the same thing with nodes. I'm going to take this, I'm going to multiply it by 1, 1, 1. In other words, don't do anything to x, y, z, just multiply it by 1. I'm then going to take the z-coordinate and just shrink it. And you can see effectively it does the same thing. So if this is your first time with vector displacement, welcome to the show. I'm going to take this, make it as thin as I want it. Again, the key insight here is we're doing it all procedurally, so we can always go back and forth and change these values in a non-destructive workflow. So for now, I'm just going to make it roughly this thin. And if you wanted to change, I'm not going to do it now, but if you wanted to change like the height and width of it, we can do that too here. And you can see it's just messing with our coordinate system. Okay? We'll say it's good for now. So again, first step, we made a coordinate system. Second step, if you think about this as a series of transformations, second step is we just flattened this z-axis by a bit, just shrunk it a bit. Next step is we want to add in some sine waves. Again, when you do this in vector displacement, just think to yourself, how would you do it normally? Well, we would add to the z-axis, this up and down, same axis we shrunk by, we'd add a sine wave spanning across the surface. Okay, so that means we need a sine wave, and it means we want to add it to the z-coordinate. Starting off with the sine wave, I'm going to be using a wave texture. And generally, this part's a bit complicated, but I would recommend if you are going to use a texture for the next step in vector displacement, if you can, always try to use like the last piece of the vector displacement you've used so far. So for example, I can plug this in here. This will just carry the transformation that we've done. You don't necessarily need to do it for this project, but it's helpful. So everything we've done so far, sending it to a wave texture. So this is going to be our sine wave. I'm thinking let's make it so that there's less corrugation. So you can see it's going from black to white to black to white. And this is going to be the number of periods, if you think about it trigonometrically. I'm going to keep it like this, okay? We can always go back and change it. So the smaller the number, the less perforations. I don't know if that's the right word. The bigger the number, the more we have, okay? We want to take this and add it to the z-axis. So again, now let's put in our next step in between the last step and our destination. I'm going to add in a vector math addition. The way you want to think about addition is it's literally just taking all these points and just moving them up or down or wherever, because we're just adding a vector to all the vertices location in that transformation. So let's do it like that, except we can combine x, y, z, so I only care about the z component. You can see this is kind of the blue channel, moves it up and down. We plug in the wave texture, since this is what we want to be going up and down. couple things you're going to notice here. First of all, we want to be viewing this with the BSDF just so we can see what we're doing. That's the first thing. Second of all, you're going to notice that it's a bit too tall, right? It's supposed to be kind of like mild waves in here. Remember, this wave texture is what we are adding to the Z component, so if we want it to be less intense, we could just multiply it before it even arrives. So we multiply it by, if it's 0, it does nothing. If it's 1, we have the same issue as before. Let's multiply it by some number in between, 0.1, 0.2, whatever. And again, if we were to look at this from the side view, you can see we are just adding the sine wave on the z-axis. And we're actually having quite a bit of geometry compressed on the edges here, but we're not going to worry about that. So we have all this. If you're seeing that it's looking a bit jagged from the profile, like you wish it was a bit more rounded, this isn't an issue with the material. It has infinite resolution. By the way, we should save it. We're going to call it Patreon Mayterial Day 1. Not promising I'm doing all the days. I'm definitely doing day 1, but I can't even promise day 2. The issue isn't with the procedural thing. It has infinite resolution. The issue is with the number of subdivisions. So again, we're using the special kind of subdivision that is called adaptive subdivision. Don't worry about it. It just picks a number on the fly. What we're going to do is we're going to make it more precise. So go from 1 to like 0.5, and you can see really cleans this up at the cost of more computation time. 0.75 is fine. So what do we have so far? What we have so far is a completely procedural setup where we can control the number of perforations. We can control the strength of those perforations. We can even control, and this part we want to add a bit more math to, but we can even control kind of the shape of this. Although now that I'm looking at it, I guess it's just working fine. My original node group was made a bit differently. So you can see as we're increasing this, it's just kind of accessing more parts of the wave instead of actually stretching it. So for example, this is why it's so useful to do it like this. I think if we were to do it the way I did it before, let's see. Yeah, this actually stretches a limited number of perforations, which maybe you want. But if you don't want that, that's why it's important to use the last step of your vector displacement. So now we can access those waves because it already knows the transformation that happened. Okay? Okay. So we have the general shape. We could add some parameters to this, but I'm just going to kind of reshape it to what I want. And then we could add in parameters later. So I'm going to make it a little less tall. Oh, and by the way, since we're controlling this with a wave texture, this is a great time to kind of choose. I mean, in this case, we want it to be like this. But you can make saw waves, and you can literally see what that looks like. So this is a good way to make like a, I don't know, something else. Here's a triangle. You can see what all these actually mean visually. I guess the saw wave would be good for like a garage door or something if you were to make it, whatever. In this case, we want it to be like this. Other than that, let me just add in the rotation, and then I think we're actually done with the vector displacement. So again, original modified texture coordinates to use generated coordinates. We made it thinner. We added in a sine wave, and then we subtracted away the original coordinate system. Now let's take this, and by the way, cool thing about node preview, you can see what the vector displacement map we are making is, or you can see what it would look like. You can see what this map looks like that gives us the transformation from cube to this. It's cool. Let's make it rotate. So again, everything we do, we put along this chain in between the final subtraction result and everything we've done so far. With vector rotate, it basically rotates all the vectors, in other words, the position of the vertices for the transformation. I'm just going to set it to Euler because this is the easiest to think about, where Z rotates it on the Z-axis, easy to think about. So you can see on this node preview, it's literally rotating our vector displacement map. We can rotate it on the X and the Y, and assuming you've done everything correctly so far, it should just work the way you'd expect. So I'm just going to rotate it so it's kind of not facing flat, and we can actually, make this look metallic and all this and get some light bounces in a way that's easy to interpret. I think we're done with vector displacement. So final thing, I always like to do this, it's not necessary, after the subtraction. So in other words, we've taken our original coordinates, we've added a transformation, and then subtracted away the original coordinates. So all we're left with is the transformation. If we take this and then afterwards set this to scale, what we can do is we can actually see this transformation. So when it's set to 0, we are scaling the transformation by 0. In other words, vector displacement isn't really working. And then as we increase this, you can actually see what the transformation would look like when you set it to 1. You can even extend it, which is weird, but it's just a thing. Okay? Cool. Next thing I want to do is the BSDF side of it. So we've done the displacement. Now let's talk about the surface. Good time to save. For the surface, I'm going to keep it super simple. What I'm going to do is I'm going to make it metallic to begin with, just to see what we're working with. And by the way, this is a good, how do I say this? This is a opportune time to see what a low amount of geometry will look like. So you're seeing all these distortions and all this. You can either fix that by lowering this number, so now you can see these lines are straight. So before we had some distortion. I don't know if it's coming through on YouTube. We save it for the render. For now, we'll do low resolution preview. So what I'm thinking for this is we're going to use a noise texture. This is going to define what areas are rusted, what areas are metallic, stuff like this. I guess it's all metal. There's just some rust on some areas. We're going to use noise texture. Now, in theory, right now, this is just using generated coordinates. You can see it's actually using generated coordinates. You have to add in the nodes to actually see it. What I'm trying to say is generated coordinates, as we talked about, move with the transformation. It's fine. So in this case, we're going to keep it. But if you have a different kind of transformation that isn't this corrugated thing, like there's more crazy things going on, again, just like before, I would recommend using the last step of the transformation as the coordinate system. I think in this case, it would be this rotation thing. Let me just try it. You can see it gives a slightly different result, but you can play around with it. In this case, it doesn't matter, so we'll just move past it. Okay, we have noise texture. We want this to generate areas of rust and not rust, etc. So first thing I'm going to do is I'm going to take this, send it through a color ramp. This is just a good way to, I guess, increase the contrast of these areas. So I'm just going to bring this up, and now that we can see which areas are which, so you can think of white as metal, black as rust, whatever. Now that we have this, I'm just going to change the actual parameters of our noise texture. So let's bring up the detail. By the way, I read a comment that the difference between 8 and 16 on detail is so imperceptibly whatever that you're just adding computation time for no reason. I haven't verified it yet, so for now I'm going to keep it at 16, but I'm sure that guy knew what he was talking about. I'm also going to increase the roughness, which is almost going to like bleed these two sections together in a very rusty looking kind of way. And again, we can always change the base level of this. So this is going to be our base map for this kind of stuff. Let's preview the BSDF. There's a lot of stuff we could do with this. We can plug it into the base color. That kind of gives an interesting result. I think technically the most accurate thing we can do with this is let's plug it into the metallic. So some areas are going to be metallic, some of them are not. In fact, let's up the contrast even more so we can see that. So you can see we have metallic areas that are shinier. It almost looks like surface imperfections, which it is. Some areas are metallic, some of them are not. And what we want to do is in the areas that are not... That voice crack was embarrassing. In the areas that are not metallic, in other words, the areas that are black, the metallic is set to 0, we want the color to be a bit different. So I'm just going to copy over. We technically don't even need a copy. We could just send it through another color ramp or even a mix RGB. Let's do it like that. I'm going to send this through a mix RGB node. And this is going to determine, with the use of a factor, which colors are the rusted areas, which are not. So the way you want to think about this, I'm going to set one to red, one to blue just for this demonstration. We are taking this black and white factor map that we made, and we're using these two colors to say in the white areas, no, in the black areas. Yes, in the black areas, which is the top socket, which is the background, it's confusing, make it red, and wherever it's white, make it blue. And when we plug this in, it would look like this. Of course, we want to pick better colors. So in the areas where it's not metallic, in other words, it's rusted, in other words, it's this top socket, let's make it kind of like an orangey, darkish rust thing. We'll play around with it. And for the actual metal, which is the blue, first of all, it's desaturated, so it actually looks like a metal. I'm just going to make it some shade of gray, depending on how worn you want this metal to be. So something like this. And now let's go back and play with the rust color. So should it be a little less saturated? Yeah. This just makes it feel more... You know what? Actually, so far, I like this result better than the one I made originally. It looks cool. This is a good start. I also want the rust to have some height because it's like accumulating and it's on the surface. And we could do that with vector displacement, actually. I'm not going to recommend it. So instead of that, let's just use some bump mapping. So I'm just going to use bump. Nope, that's an attribute node. I'm just going to use a bump node, which converts, as you know, factor information into vector normal mapping information. So you just take this, connect it to the height. You can see we now get a generated normal map. That's an approximation of what it would be. Either way, it's taking some kind of gradient or derivative. You plug it into the normal. And then you can see, wow, it's rusted. It's actually probably too intense. So take the strength, bring it down. This is just going to be the weight or the strength of this normal map. So you can just kind of pick what you want for this. Again, depending on how rusted, how corrugated you want this thing to be. I'm thinking even less, something like this. And by the way, one thing I realized that maybe we should do just for the vector displacement step, and you can kind of go back and forth, it doesn't really matter. For now, let me just reset this rotation to 0. I'm thinking this is looking all very good and all that, but why don't we just add a bit of randomness? So I'm just going to do that. Before we rotate this thing, or I mean, I guess we can have it rotated, but before the step where we rotate this, we can also add in a bit of randomness. So this just makes it look more dented and not like this perfectly shaped thing that's rusted. I also want the shape to be weird. Easy way to do this. Anytime you want to add in some randomness, just use some kind of noise texture. This is just a source of randomness. Again, I believe what you want to do is use the last vector displacement step up till that point in this. So here's what that would look like. Here's without, here's with. It's actually stretched for our mesh. What we're going to do is we're just going to mix these things together. So I'm going to mix RGB. Again, we're taking our coordinate system and mixing it with some randomness. So let's use the color. And you can see, I mean, it accomplishes the mission. Let's see it through the eyes of a BSDF. It really mangles our mesh a little. And you can see what's happening here is it's taking our coordinate system and adding in some randomness that's controlled by this slider. So this is the randomness that's being added in. So assuming we keep this at a small number, not a big deal. But also you can see it's doing some weird stuff where it's moving it to the corner. And you can see this with the node preview as well. There's some, I explain it literally every tutorial, so I will spare you here. Just set this to linear light. The reason it works is I just said I wouldn't say it. It basically subtracts a vector that needs subtracting. So I'm just going to take this, I'm going to increase it by a tiny bit so we have some distortion. Now let's, again, modify the quality of this distortion so it can be super detailed. It can have some roughness, maybe low roughness, I don't know. Something like this, and now we can pick how much intensity it should have. Okay, so this is super subtle. So here's the before and after. I don't know if you can even tell a difference. Maybe we should make it a tiny bit stronger. I'm just adding a tiny bit of randomness, so it's nothing crazy, but there we go. You can also change the scale of this for the size of the. Either way, they're just a tiny bit of a detail. Let's go back to the BSDF stuff where we belong. So we added the color, we added the change in metallic, we added some normal mapping. Final thing is I just want some kind of like with this mesh, I want some, it's not corrugated lines, I just want some lines of like the grain of the metal, like how it was cut or something like this. Again, I don't know what I'm talking about with this. I'm not a construction worker, but I do think it looks cool. So what I'm going to do is I'm going to add in a wave texture just like before. You can see it's mapping kind of correctly. In theory, you should be using the last step of this. Seems fine, so we'll just do it like that. These are just going to be lines that I want subtly affecting the normal map. So I'm going to have a bunch of these, something like 25, adds in a bunch of lines going along here. For the bump, what I'm going to do is I'm going to add in a contribution, in other words, addition of this wave texture. So you can see now we have not only this rust stuff affecting the bump, but also these corrugated lines that aren't corrugated. And you can see when we actually view this thing, there's some very subtle lines that are also affecting the normal map, not the actual mesh or the vector displacement, or yeah, just the VD, but it's just the normal. Just to control the strength of this, I'm just going to throw in a multiply here and make it, when it's 0, it's not going to be visible. When it's like anything 1 or above, it's going to be crazy. I'm just going to make it 50% visible. So multiply by 0.5. Okay. So in general, let's see what we have so far. So we have the whole vector displacement thing. We can rotate it. We can put it wherever we want. We can even add in noise. Don't want to do that too much. We can control. I'm trying to find the slider for this. We have created quite a mess here. I'm looking for the multiplication that we did. It was compressed. We can control the size of this, and it's going to procedurally add in the rust and all this. That's cool. And yeah, we could do all these things. By the way, this is a good reason, by the way, to be adding in this vector rotation here as well. Because if we were to view, what am I trying to show you? If we're trying to expand this, it's going to do some weird, whatever. And don't look at the mesh, just look at the texture that's on it. You can see it's looking good now. Whereas if we did not connect this, it would kind of stretch the rust. So that's why I'd recommend it. But when you increase it like this, I would recommend lowering your dicing scale even more to clean that up. So let me just go to 1.3. Long story short, we have a fully procedural corrugated metal thing from what? From a cube. So you can see, this is how people make that kind of stuff. I'm trying to think if there's anything more I should go over here. I mean, we could make it look much, much more realistic by like just, here I'm just setting up a scene. This has nothing to do with what I'm talking about, but we can make it look much more realistic by diving into this BSDF. But I think the important theory of it, the vector displacement, the normal mapping, all this, it's been covered at this point. So I think that's the end of this CG Matter tutorial. Fuck it, I'll just put it on the CG Matter channel. So hopefully you enjoyed, hopefully you learned something. I'm not promising any more Mayterial tutorials, although I might do some more. I'm just not promising anymore because, you know, they're hard, they're tricky, there's a lot to learn there, and we're kind of appealing to the advanced audience. Anyways, as I've been babbling, what's been going on the right? Is it a list of the perforation, corrugation, me saying that word on the thing? No. 700 plus some patrons. You can join their ranks by going to a link in the description for that. And why would you want to join Patreon? Well, first of all, you already know this blend file is going to be available. I told you, any blend file I've made over the last 2 years that I've posted on Patreon, you can get access to as well. You can also get exclusive tutorials that are not on either channel. I'll probably do some more Mayterial stuff exclusively since I'm not planning to do it all. So that's probably a place you could get that. Additionally, Discord access, early access to some tutorials, stuff like this. So yeah, Patreon's a bopping spot, and another random 27 minute-ish tutorial in the bag. Hopefully you enjoyed, hopefully you learned something. Thanks for watching, see ya.